So let's see the chemical properties of acid and alkali. So for acid, the chemical property, the property of acid can be divided to physical and chemical properties. So the physical properties of acid is sour taste, corrosive. Okay, the pH value of aqueous solution is less than 7, and it turns moist blue litmus paper red. And this is the reaction between the acid and base, or we call alkali, which produce the salt and water. So normally acid plus base or alkali, it will produce salt and water. Salt is neutral. Okay, like HCl with magnesium oxide, it becomes magnesium chloride, which is a salt with water. Sulfuric acid with potassium hydroxide become potassium sulfate with water. Nitric acid with sodium hydroxide, it becomes sodium nitrate with water. Okay, so this is how it normally looks like. So this is the, what I call it, the general formula for that. All right, jot this out. Done now. So next, let's see. The reaction between acid and reactive metal will produce salt and hydrogen gas. So this is how. So like 2HCl with zinc, it will become zinc chloride with hydrogen. Sulfuric acid with calcium become calcium sulfate with hydrogen. It's like a substitution process where the reactive metal will substitute the hydrogen out. Okay, so where the hydrogen nitrate, okay, nitric acid actually with magnesium, it become magnesium nitrate with hydrogen. Okay, can all right, jot this down. Okay, so let's see the reaction between acid and metal carbonate will produce salt, carbon dioxide gas with water. Like HCl with calcium carbonate, it will become calcium chloride. This carbonate will become carbon dioxide and then combined with the hydrogen become water. Okay. Same goes to nitric acid with zinc carbonate. It becomes zinc nitrate with CO2 with water. Okay, like sulfuric acid with sodium carbonate, it becomes sodium sulfate with this carbon dioxide with water. Okay, so jot down this one as well. But remember, the most of the part is this one. Okay. Done, huh? All right, now let's see the chemical properties of alkali. So for the physical properties, okay, you have bitter taste, soapy feel, means that when it's in we call in solid, the surface feels slippery. Okay, so the pH value under aqueous solution is more than 7, and you turn moist red litmus paper to blue. Now, when we heat, the heating of this alkali with ammonium salt will produce salt, ammonia gas, and water. So this is called entropy. Okay, this one is called entropy. We call heating. Okay, like sodium hydroxide with ammonium chloride will form sodium chloride with ammonia and water. Calcium hydroxide with ammonium oxide will form calcium nitrate with ammonia with water. Potassium hydroxide with this ammonium sulfide, okay, will form this potassium sulfide with sulfate, sorry, with ammonia with water. Can I? Okay, jot this down. Okay, this one also need to jot down, but remember, the main idea is this one. Okay, all right. Okay, so next. Now, reaction between the alkali and acid will produce salt and water. Okay, this one we already actually mentioned just now. Some of these are actually repeated. Just now, remember the acid one that we already have. So this one, you just need to copy this one is more than enough. Because it's part of the property. When they ask, then you need to give. And when aqueous alkali is added to aqueous salt solution, so there will be an insoluble precipitate of metal hydroxide. Okay, is formed. Is okay, where like for example, two sodium hydroxide with copper sulfate will form sodium sulfate with copper oxide hydroxide. Sorry. Okay, sodium hydroxide with iron chloride forms sodium chloride with iron, we call that the iron hydroxide. Okay, which is rust. So it should be around green or brown color. So sodium hydroxide with magnesium nitrate will form sodium nitrate with magnesium hydroxide. Okay, where this one is wrong, I think. This one is wrong. It's actually alkali with salt. This one, it should be alkali with salt will form will form soluble salt. Soluble salt with plus the insoluble metal. Metal hydroxide. Okay. So this is the general formula. Okay. So jot this on. This one only. This one just jot down this one only. Okay. All right. Jot down this one. Okay. All right. So let's this one now. Okay. The school now until chapter where? Which chapter? Was still in chapter 5, but already exam. And exam until chapter what you call? Chapter 8.
But chapter 8 now. Involved in the chapter 3. Originally, the chapter 8 is involved, but the exam doesn't.
Oh, really? So means that they received the wrong information. Means the UP3 is not done by your teacher. It's maybe coming from maybe the what you call that ABS, maybe high chances. Normally the one who involved in exam questions is either KT, ABS, science normally ABS, science stream normally ABS and Hualien. I think KM is and this KT mostly involved in the account, the business account, perdagangan, all this. I try to do this. This is to how to say. This is to train whether your chemical equation. See whether you still remember the formula for each substance or not. Okay, so let's see the answer. Now, sulfuric acid with barium hydroxide solution will form barium sulfate with water. Okay, nitric acid with copper 2 carbonate powder, it will form copper nitrate with carbon dioxide with water. Hydrochloric acid with zinc granule. Zinc granule means zinc. Okay, means you will form zinc chloride with hydrogen. Iron 3 chloride solution with potassium hydroxide solution. You will form potassium chloride solution with ferrum hydroxide. Ammonium chloride with sodium hydroxide, you will form sodium chloride with ammonia with water. Zinc ion with potassium hydroxide solution, you will form zinc hydroxide with potassium ion. Okay. Okay, done, huh? Còn là gì? Done, huh? All right, so let's continue. So the concentration of aqueous solution. So how we calculate the concentration? So the concentration is actually a measurement of solution. Okay, no, the measurement of, we call not solution, the solute in the solution. Solute is like zinc chloride solution. Zinc chloride is the solute. Okay, the measurement of the solute in a standard unit of solution. Standard unit here normally is dm cube, not cm cube or meter cube. No, it's dm cube. Is it correct? Yeah. So it's a measurement of that shows the quantity of solute in 1 dm cube of solution. So the more the solute, the higher the concentration. So the quantity of solute can be measured in gram or mole. So the concentration of solution, we are measured in gram per dm cube or mole per dm cube. Normally in chemistry, we use molarity. Molarity means that it's called mole per dm cube. Mostly now we are using mole. Okay. So the formula for this one, for mass of solute in 1 dm cube of solution is we're using the mass of solute divided by the volume of the solution in dm cube. Gram and dm cube. For the numbers of mole, we're using the numbers of mole divided by the volume of solution in dm cube. So normally 1 mole per dm cube we call 1 molar. Okay. Yeah.
1 molar means 1 molar.
1 mole per dm cube. Yeah, 1 molarity. Molarity is the name for that unit. Molar is the unit. Okay. Okay, run this down. Done, huh? So you see, okay, okay. So for concentration, if you want to get molality, you just need to divide by molar mass. From molality, you want to get the concentration, you need to divide by the molar mass. Molar mass means that how one mole, how much the mass is. Okay. So calculate the concentration of the following solution in the unit of gram per dm cube, like 10 gram dissolved in 0.2 dm cube of water. So 10 gram divided by 0.2 is 50 gram per dm cube. Okay, remember, 1 dm cube is equals to 1000 cm cube. So 18 gram of potassium hydroxide is dissolved in 750 cm of same cube of water. So 18 gram divided by 0.75 because we use 750 divided by 1000. So it equals to 24 gram per dm cube. Okay, now? All right, so you jot this down first. You jot down this one with the questions as well. Huh? Done, huh? So try these questions. You see, huh? Done, huh? Okay, so the answer shall be 50 divided by, or this one should be 2000 is 2, 2 dm cube, so the answer shall be 25. Okay, 25 gram per dm cube. Now, determine the concentration of 99 gram of ammonium sulfate in the 1.5. So 99 gram divided by 1.5 is 66 gram per dm cube. Okay, so calculate the molality of 0.5 mole of solid calcium chloride in 500 cm cube of distilled water. So it will be 0.5 divided by 500, which is 0.5 as well. So you will get 1 mole per dm cube. Okay. Now, for number, oh, so many. So calculate the molality of this one, 0.5 mole per dm cube, okay, in the unit of gram. So first, we try to get the molar mass first. 2H2, S is 32, 4 times 16, you get 98 gram per mole. So just now we said, use the molality times the molar mass to get the gram per dm cube, so you get 49. Okay, so this one is he gives you the molality 0.2 mole per dm cube. He wants you to get the concentration of sodium chloride solution. So you use 0.2 times the molar mass. So the molar mass for this one is Na is 23 plus 35.5. So 0.2 times 33 plus 35.5, you get 11.7 gram per dm cube. Try this. Done, huh? So the answer, let's see. So what's the molality of 32 gram per dm cube sodium hydroxide solution? So this one to change is using this one times the molar mass. So the molar mass for this one, NaOH will be 23 plus 16 plus 1. So you get, okay, the mole per dm cube, this one moves here. So the mole per dm cube will become 32 over 40, which is 0.8 mole per dm cube. Now, the concentration of barium hydroxide solution is 68.4 gram per dm cube. So he wants you to change to molality. So using the same formula, molality, the concentration is 68.4 equals to molality times the molar mass. So actually it's divide. You straight away, if you want to do it straight away, is the concentration divided by the molar mass. So the molar mass for barium hydroxide is 171, so you get 0.4 mole per dm cube. Okay. So let's see so the numbers of mole of solute dissolved in the solution we can calculate by using, it can be calculated if they provide with you the molality and the volume of the solution. So the molality is numbers of mole divided by the volume of solution. We call N over V. Okay. So if you move this here, N is equals to MV molality times volume. Okay, in terms of dm cube, of course. So if the volume of the solution is the volume unit of cm cube, then the unit of volume we should convert to dm cube. So it will become mv over 1000. So sometimes we also get mv over 1000 if it gives you in cm cube. Okay, this one we already mentioned just now, so I didn't ask you to copy. So now, for 2.5 dm cube of potassium chloride solution, okay, in with 0.02 mole per dm cube. So N is equal to MV 0.02 times 2.5, so you get 0.05 mole. 300 cm cube of sodium hydroxide solution, 0.5 mole per dm cube. So it becomes 0.5 times 300 over 1000. So you get 0.05 mole. Okay, quite fast, huh? So try this one. Done, huh? All right, so let's see the example. Continue. So what's the number of mole of glucose contained in 100 cm cube of glucose solution with 2.0 mole per dm cube? So we just use MV over 1000 because it's cm cube. So you get 0.2 mole. Calculate the numbers of mole for potassium hydroxide of in 2.5 dm cubes, okay, with 1.2 mole per dm cube potassium. So 1.2 times 2.5, so you get 3 mole. Calculate the mass of this, okay, for this with this concentration, okay, of calcium hydroxide solution of this one. First, we try to get the numbers of mole first. MV over 1000, which is 50 times 0.01 divided by 1000. So you get 0.0005 mole. So for the molar mass, so 0.0005 times the calcium hydroxide. Calcium is how much? 40. So then this one is times 2, okay, plus 2 times 16 plus 1. So you get 0.037 gram. Okay. So what is the mass of potassium hydroxide needed to produce 250 cm cube of 2.0 mole per dm cube potassium hydroxide solution? So you use MV over 1000 again. Okay. So you use 2.0 times 250 divided by 1000. So you get 0.5 mole. So like just now, using the mole to find the molar the mass. So you use 0.5 times the molar mass. So you get 28 gram. Okay, this one pretty easy, Anna. So let's see the standard solution. So what is called standard solution? Standard solution means that the solution that we already confirm the concentration. Okay, so it's a standard solution is the solution that the concentration is accurately known. So normally in the preparation of that, the mass of solute and the volume of distilled water are two parameters that must be measured accurately. So for example, 250 cm cube of a standard solution of 0.2 mole per dm cube sodium carbonate can be prepared by putting a required mass of sodium carbonate and distilled water into a 250 cm cubes volumetric flask. So, okay, correct. So first, we try to get the calculation first, okay, where 10 gram, okay, 10 gram of this glucose is dissolved in 0.2 dm cube of water. So you get MV, so 0.2 times 250 over 1000, which is 0.05 mole. Okay, provided here and here. So you want to get the mass, so you use 0.05 mole times the multiply with the sodium carbonate's molar mass, which is 46 times this one is 23 again. Okay, 23 is 46 plus 12 plus 48, 16 times 3. So you get 5.3 gram.
So you also use the same formula.
Yeah, like the one just now is he already provide with you everything. This one is actually the same thing, The one that we have is concentration, how much, right? That one is also considered as a standard solution. So the calculation is almost similar. Okay, so jot this down. And the calculation as well, this one. Done, huh? All right. Mm, all right, let's see the how we do the solution. Huh? So first we add the distilled water, okay, and the solid sodium carbonate, okay. And then this one is with the what I call with the mass. We're using this formula, okay, to calculate how much we want. Then we dissolve the solid, and then we transfer the solution a little bit one to the volumetric flask, because the volumetric flask is standard one, like 100 cm cube. The line is there. So if your solution until 100, so means that 100 cm cube. Okay, and we refill the water until the solution meniscus level reach the calibration mark. Okay, of course, a little bit less, then we drop it drop by drop. Okay, and we lock it. So this is how they do the standard solution. That is especially they do it for your usage in your lab. Okay. All right. So let's see, okay, to make standard solution. First, the beaker and filter funnel should be rinsed with distilled water so that to ensure all the residual of sodium carbonate on the wall of the beaker and the filter funnel are transferred into the volumetric flask. Means that I clean it a bit with the solids, with the distilled water, and then I masukkan it into the flask. And all the water used for rinsing should be transferred into volumetric flask to ensure the standard solution has an accurate concentration as desired. This is to make sure all the residue are inside there. And to make sure the meniscus level is in line, so the eye level should be aligned with the meniscus level observed. When we try to check with our eye level should be on the same level with the meniscus level. Okay, this is to prevent the zero error. Okay, and the volumetric flask should be closed with the lid to avoid evaporation of water, which may cause the concentration become lower, higher. Okay, so this is the one that you need to jot down. Okay, just now the standard solution, under the standard solution, okay, you put in the discussion. Done, huh? Okay, so I think I will stop here for today. So any questions? No, huh? Okay, no, I will stop there. See you on next.